Episode 1, I explored using color isolation in a video editor as a way of gathering more information about light anomalies captured via digital cameras. This exercise made me realize how much more I needed to learn about video and film editors, and also digital cameras. Sometimes I analyze video for other people who are exploring other phenomenon, and I know what it's like to want to glean as much information as possible from footage. One of my biggest frustrations when doing analysis for myself and others are the distortions that are encountered when zooming in on areas of footage. This is referred to as interpolation. I knew it was partially related to lighting and the camera sensor. I really wanted to learn more about the limits of my cameras and wanted to learn more about interpolation. The best way to learn is to do. So what is interpolation? When we capture an image or a video with a digital camera, what we're really collecting is a grid of pixels, which are tiny squares, each recording a value for the brightness and color. But there's a catch. Each pixel doesn't actually capture full color information. Most camera sensors are covered with a pattern called a Bayer filter, which lets each pixel record only red, green, or blue light, not all three. This means that 2/3 of the color information is missing from every single pixel. So how do we end up with full color images? That's actually where interpolation comes in. Interpolation is the process of guessing or estimating missing data by averaging the values of nearby pixels. The camera, or later editing software, fills in the blanks using mathematical formulas. In other words, it's not just showing you what the sensor saw. It's showing you what the software thinks was there. Interpolation happens automatically in hardware, within your camera, within the editing software, or both. If all of this is starting to make you skeptical about the reliability of digital cameras, you can stop right there. Did you know that digital cameras are based on the physiology of the human eye and the processes used by your body to transform light captured in the cones of your eye to meaningful images? Just like the digital camera, you have 3 different types of sensors, also known as cones, that actually capture only red, green, and blue light. Just like the digital camera, your brain uses the intensity of these 3 colors to sense the billions of variations of colors. Your brain actually has its own version of interpolation. Anyone see a big black hole in your field of vision? Well, you would if your brain didn't compensate for the gap of light-sensitive cells where your optic nerve connects to your retina. Your brain uses contextual visual information from the surrounding areas to fill that missing space, just like a digital camera uses mathematical formulas to fill in blank pixels and to determine what colors you see in a picture. This is biological interpolation, and it's doing just what your digital camera does when interpolating pixel data. If it's good enough for your brain, it's good enough for our digital camera. Now back to the show. If you are using digital cameras in your work, you have no doubt heard people say you should film in RAW format if your camera offers this option. RAW files contain the unprocessed output of the camera sensor. That means they store the exact data from each pixel site without compression, sharpening, noise reduction, or color interpretation. The problem is not all cameras have RAW format, and also RAW files can be quite large, and if you do not know when or if you are going to capture your target, filming in RAW format might not be practical. You need an incredible amount of computer power and space to process large RAW files. For the sake of this video, what I'm really trying to do is figure out the best way to identify the trust thresholds for the cameras that I'm using. I want to know what distance do they produce the clear images, and from that distance, when I zoom in, can I trust what I see? If I can identify an experiment and a process to understand my own gear, perhaps it will help you understand yours. This channel is about sharing information across the community, and maybe this is the first step to tackle a problem many of us have experienced. Okay, we're doing our interpolation experiment, right, Meg? Okay. We started off filming at 150 feet away from our target. And this is the setup. I'm not going to show you what our target is yet. I'll film it later. So I have my Lumix G95 and I'm filming both. I'm taking shots both at the zoom of 25 millimeters and again at 35 millimeters. And the GoPros, I will write out all the settings for the screen, but I'm filming on the GoPro 11 and GoPro 10, and I'll let you know exactly what settings I used. But we are filming in 10-foot increments. We started off at 150, we just filmed 140, to that little step ladder I have out there. And I have some objects on the step ladder. The purpose of this project, the purpose of this experiment is to show you the wide shot for each of the cameras and each of the settings that I have for the Lumix, and then zoom in via the software. Now, when you zoom in via the software, the interpolation that you see is due to the fact that not all the pixels had data in them, so they're really guessing at what the value of the data is. And the goal is to see at what point each camera can actually tell what the objects are in the regular view, but more importantly, the zoomed view. What this tells us is the limitations that we have on our zoom for each camera due to the interpolation. So what I'm looking for is the point in the zoom where you can identify what the objects are, zoom details where you can identify the details of the objects, and then the wide shot ID where you can identify the objects via the wide shot, and the wide shot detail where you can clearly see the details of the objects. When viewing the results, you will see certain areas where I identify the points where the zoom ID details, the wide shot ID, and wide shot details become visible for each of the footage. You'll see some points where sometimes the zoom details actually get worse after the point where I'm able to identify them, and that's due to a change in lighting, but I left the results as it stands. So even after you do the experiment, you will identify other lighting conditions that could impact the interpolation. Here are the final results of the polation tests. You'll note, if you look on the left, are the results of the zoom trust thresholds, and on the right are the results of the wide view trust thresholds. And the numbers in the middle, you'll note, start from the bottom, and they start at 150 feet and they move up to the 10 feet. The red parts of the bar represent the low confidence parts. So, for example, on the second column under zoom trust thresholds, Lumix 25 millimeters, you'll see that between 150 and 100 feet, it says there is a low confidence. The 90 feet is the yellow. That's where you could detect via the zoom what the objects were, but you couldn't see them quite clearly. And starting at 80 feet all the way up, you could see clearly what the objects were. So it's pretty clear that the Lumix 35 millimeter was the winner here for the zoom and the wide view test. And the GoPros didn't do very well at all. But the one thing that it's important to know is the 35 millimeter is a pretty narrow field of view. Even the 25 millimeter is a lot narrower than what you can see with the GoPros. And it seems like the more narrow the field of vision is, the clearer you're able to zoom in on things. It's not just the sensors are much better on the Lumix than the GoPro, of course. The GoPro has a lot of good features. I can't see using the Lumix in the way you use the GoPro, so that's an issue. A lot of people put the GoPros just on their packs and they film their entire walks in the woods, for example. You're not going to do that with the Lumix. So I know there are smaller cameras like the DJI, the Osmo, that is said to have a much better sensor. It'd be interesting to run these tests. But what I was trying to get at here is this has given me a lot more insight in how to use my cameras and what to expect from them. So for the GoPros, you can see pretty clearly within the field of view if a person is walking quite far away from you. You can still see that it's a person and you can see what it is. It's when you start to zoom in on the background that it's important to understand what the limitations are and how much of what you're seeing is actually caused by interpolation that may not be being done very well. And that was the whole point of this exercise. It would be interesting to hear how many other people try this and what they experience. But it really does, I think it will also help me understand and judge distances from the cameras and the videos that I have. The point of this isn't to trash any particular camera or to indicate that digital cameras aren't useful tools, because they absolutely are. It's just an effort to understand exactly what's in the background, what goes behind generating that image.